So in an earlier video, we talked about how to multiply and divide with sig figs, but that may raise the question, what about addition and subtraction? And that's what this last video is going to take a look at. So to start, you want to look at this cartoon. You can see one scientist says this dinosaur bone is 65 million and 23 years old. The second scientist says, well, how do you know that? And the first scientist replies, well, it was rated as being 65 million years old, and I got it 23 years ago, so clearly it must be 65 million and 23 years old. Now you may have a sense that doesn't sound quite right, and you would be correct if you felt that way. So we're going to actually start with the rule for adding and subtracting with sig figs, and then we'll look at this problem to help sort of explicate what we mean by that rule. So the rule is that when you're adding or subtracting, you can only report an answer to the largest decimal place that has uncertainty in any piece of data you used. In that addition or subtraction calculation. So what do we mean by that? We'll use this dinosaur example to try to explain that. So the original dating was that it was 65 million years old. Right? So we know from our last video those zeros are not significant figures. They're to the right of the digits, but they're not to the right of the decimal places. These are just placeholders. They're letting you know that's 65 million. If you got rid of them, it would just look like 65. Okay, so those are placeholders. That means our only two sig figs are the 6 and the 5. The 6 we should know pretty exactly, but the 5 as the last significant figure, significant digit, has a little uncertainty. And so we always assume, remember, that that's about plus or minus 1. So what this date really means is this dinosaur bone is believed to be between 64 million and 66 million years old. We don't know exactly how old it is. There's some uncertainty there, and the uncertainty is in the millions place. Now, the fact that it was obtained 23 years ago, we know actually the tens place and the ones place. We probably don't know the tens place. They probably didn't look at what month they got it. They're probably just estimating. So there might be a little uncertainty in that 23. It might actually be closer to 22 or almost 24 years. But at any rate, we've got two sig figs here and two sig figs here. But the way we're going to add these together to get the total age is first we just do the math. And you would, of course, get 65 million and 23, just like the scientist did in the problem. However, what we're saying here in our rule is we can only go to the largest decimal place that has uncertainty in any piece of data. Well, in the first piece of data, the uncertainty is in the ones place. And so we could, in theory, go to the ones place. But in the 65 million years, the uncertainty is in the millions place. That's the largest decimal place. By that I mean the millions place is a larger place than the ones place. So this is what we're limited to. And what we're really saying is, if we don't know exactly how many millions of years this is, these ones and tens, we totally don't know those values. Adding 23 there, we don't really know what difference it makes, because this number might have been as low as 64 million, in which case this is now just 64 million and 23. So to claim that we suddenly know exactly what the ones place is just isn't accurate. We don't know that that's a 3, because we have no idea what any of those digits really are. So we're forced to round to 65 million. So in the end of the day, the age that we would have to report hasn't changed. Those 23 years don't really make much difference when you have uncertainty in the millions place. Okay, so that's generally the rule for addition and subtraction. Just want to show a couple interesting things about that. One thing to note is you can sort of gain or lose sig figs when you add or subtract. So let's say you measure two lengths, a piece that's 65 centimeters and a piece that's 72 centimeters, and you're going to add them together, and you want to know how long will the piece be when I put these two things together. Well, you just do the math, and you get, well, it should be 137 centimeters. can we keep all 3 of those digits? We started with 2 digits in each. Under the multiplication rule, we'd have to round it to. But we should be able to keep to the ones place. Both numbers, we have a good estimate of the ones place. And so in the final answer, we will also have that. And so in a sense, it kind of looks like we gained a sig fig. And sometimes that will happen when you add, and that's okay. And it really, it does make sense if you think about it. There's a little uncertainty in 65. It could be as low as 64 or as high as 66. And the 72 could be as low as 71 or as high as 73. If we assume both of them are the high end, though, the value is 139. Conversely, if we said they were each on the lower end, the total value would be 135. This is kind of the range of values that might make sense. And 137 is a pretty good indication of that. A little bit of uncertainty in the 7 is appropriate there. Now, in the other direction, let's say you had a 72 centimeter piece and then you were cutting off 65 centimeters of it and you wanted to know how much was going to be left. Well, when you do this subtraction, you find the remaining piece should be 7 centimeters. I had 2 sig figs here, 2 sig figs here, but I only get 1 there. That's correct here, though, because I only know to the ones place. I don't suddenly gain knowledge of the tens place because I did subtraction here. I didn't know tenths here. I don't know tenths there. I can't know the tenths place down here. So you can also lose a sig fig when you subtract. So you do have to keep in mind the difference between these rules for addition and subtraction and multiplication and division. Mostly you multiply and divide, but you will subtract and add occasionally, and you need to look at the decimal places in those circumstances. So we'll practice some of these in the lab and on the homework, and you'll get used to that, but just be aware sometimes those subtraction or addition problems sneak up on you. Can't use that multiplication rule for those.